Welcome to Low Stress Math with Mrs. Bono. This is Algebra Prep Book 1. We are going to be starting with a review of some 7th grade topics. And every one of the packets that we do is going to have all the topics listed, the lesson numbers, and then we're going to write the dates that we do the packet on this page. So that way you know when you did something, and if you're absent, you'll know what to look for. So let's start with the first page. Oh, that's not the first page. That's the first page. Put your name there. I'm gonna write, what's a good name for me? Yeah, YouTube. And I'm El Bono. And this isn't a class period, but you write your class period that you have me down here. Let's say it's class period 117, because sometimes it feels that long. All right. The first day of class this year is September 5th. So that's the first date that we're going to write in here. 9/5. And this is 2022. Now, you may be watching this in 2027. It's because I'm lazy and don't like to make new packets all the time, and I certainly don't like to make new videos. So, skipping on to the first page. Lesson 1, warm up. Here's what I'd like you to do. I want you to turn off the video and I want you to think. Oh God, not that. Yes, thinking. And what I'd like you to think about is how you used math today. So take a second and turn off the video. Okay, that was long enough, right? What did you write down? What are the things that you used today that involved numbers? Now, not all numbers are math, but we'll talk about that in a little bit. So, I woke up this morning to my alarm clock. And that had numbers on it. Now, my alarm clock happens to be on my phone, and if you turn on your phone, it has a lot of numbers on there, right? Oh, well, I'm doing this video a little early too. So, used my alarm clock. Another thing, well, I know what classroom I'm in, so I used my room number to find my classes. And another thing I did was I stopped off this morning at the store and I bought myself a hot cocoa. Now I know it's a little warm in September for that, but I felt like cocoa this morning. But in order to get that, I needed money. And that's only 3 ways that I used numbers before I even did anything in class. You could have unlocked your locker. You could have, I don't know, taken a bus to school, and the bus has a bus number on it. Now, those aren't math. Those bus numbers are just designations, like zip codes. Zip codes are numbers, but they're not the kind of numbers that you use to do math. Zip codes, at least on Long Island, are alphabetical. That's why Bayshore is 11706, but Brentwood, which is BR, it's a little further along in the alphabet, is 11717. So as you go further in the alphabet, the zip codes get higher and higher numbers. It's very interesting the way that was set up, but not so much to do with how we're going to use numbers this year. Let's take a look on the first page and talk about the real number system. Now, this is a review of 7th grade. You know how I know that? Because I teach 7th grade, so I know that you did this last year. Some of you may have even done it with me. But let's take a look. The inner numbers, and I'll make that really big so people can see it. These inner numbers are labeled natural, and I use the number 4. Natural numbers are counting numbers, and it's natural to start counting from the number 1. If you talk to a small child and you say count to 10, they start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They always, 1, 2, 3, 4, 5, 6, 7, 8, whatever, they start with 1. Now, I'd like you to put your own natural number in there. I'm going to write mine too, but you can't see mine. I'm sneaking. I wrote 2 numbers, 3 and 17. Those are counting numbers. Even though 17 is over 10, I could write down 115,687. It's still a counting number. I could count that high if well, no, I couldn't. It'd be very boring. The next oval is whole numbers. Now, I always remember that it's counting numbers plus 0. Why? Because right in the middle of the word whole is an O. And a 0 kind of looks like an O. So 0, whole. Makes sense. I have a friend who says, oh, I remember it because a hole has nothing in it. So if you dig out a hole, there's nothing in the hole. That's why it has 0. But it's not just 0. It's 0 and all these natural numbers. So 0, 1, 2, 3, 4, 5, 6, keeps going. All right, the next is integers. Integers are positive and negative whole numbers. Now, if you're doing temperatures, that a positive number would be like the temperature of my classroom, which is 72 degrees. A negative whole number would be something like -4 degrees. So temperatures are a good example of integers, positive and negative whole numbers. So I could have -4, I could have +4, I could have 0 between those two. Those are all integers. Now, on the outside, it's broken into 2 parts. And it's hard to read, but that says rational. Now, rational numbers include all the positive and negative whole numbers, but also the positive and negative mixed numbers, positive and negative repeating decimals, positive and negative fractions, and some square roots. Now, this square root is the square root of 9. The reason it includes the square root of 9, because the square root of 9 is equal to 3. Some square roots are rational. Now, the definition I learned of rational is that you can turn the number into a fraction. So you can turn a whole number, like 3, into a fraction, 3/1. This one's already a fraction, 3/4. -2.5. Well, that's equal to the fraction -5/2. If you can turn it into a fraction, it's rational. But what about this thing? Repeating 74s. Well, let's see what we can do with that. 6 and 74, oh, look at me putting in the wrong numbers. I can't believe I do these things sometimes. So, 6 and, you always say decimal as an and. 6 and 74, 74, 74, 74, 74, 74. And I could go on forever. And it's just going to keep repeating. Now, on my calculator, I have this amazing little double arrow button that changes things into fractions for me. And it changed that repeating decimal into the fraction 668/99. It's still a fraction. It's a weird fraction, not gonna lie, but it is a fraction. So I'm gonna write that down, 668/99. So all of these rational numbers can be made into fractions. All of these integers are rational because they can be made into fractions. All of these whole numbers are rational because I make them into fractions. Natural numbers, you can turn them into fractions. Now we get into irrational numbers. So that's pi. Pi is a number. Don't let anyone fool you. It's 3.14159, blah, blah. I don't even remember after that because it's exhausting. But it is a number key right here. And if I hit enter with those little double arrows again, it turns it into 3.141592654, blah, blah, blah. So it never ends and it never repeats. It's a really special number, but it's not rational. Irrational things never end and never repeat. How about the square root of 3? Let's look at that. How do I do that? Second, x squared 3. See? Square root of 3. You can't see. There we go. Square root of 3. And that just comes up, the square root of 3, What if I hit my little double arrows? Now it looks like a nice decimal, but that's a never-ending, never-repeating decimal. So that's also irrational. Irrational never ends, never repeats. So the natural numbers are counting numbers starting with 1. So let's write that in there. So I'm going to use a set, which is a curly bracket, a C, an arrow, and a C. That's a curly bracket. 1, 2, 3, 4, 5, and then 3 dots, which is an ellipses. That means it's going to keep going on forever. Now, whole numbers are all of the counting numbers. Starting with 1 and 0. So it's all the counting numbers and 0. And you should be able to read this a little easier. There we go. Example, again, curly bracket, 0, 1, 2, 3, 4, 5, dot, dot, dot. Now, if you want, this is actually going to go on and on and on and on forever. So I could put an infinity sign, because it is infinite. Counting numbers are infinite. Now, integers, those are positive and negative counting numbers. So all of the counting numbers and their opposites. So all of the whole numbers and their opposites. And what do I mean by that? Well, let's take a curly bracket, and I'm going to start here with 0. The opposite of 0 is 0, it's nothing. But the opposite of 1 is negative 1. And the opposite of 2 is negative 2. And the opposite of 3, negative 3. So it's all the counting numbers and their opposites. And it starts at negative infinity and goes on to positive infinity. Right. Rational numbers are all of the above, including fractions and repeating or terminating decimals. Repeating, that's obvious. Terminating means it has an end, and I mispronounce it all the time, but that's okay. So, rational numbers, all of the above, including fractions and repeating or terminating decimals. So, what are you talking about there, Bono? Let's start with a curly bracket. And how about a negative infinity? Haha. And say negative 3, negative 2.6, repeating, negative 2, negative 3 over 2, negative 1, 0, 1, positive 3 over 2. Goodness gracious, this could go on forever, Bono. I'm going to go to positive infinity then. There we go. It's everything that repeats or ends. That little line above the 6 means it's going to repeat. And fractions can be positive or negative. It's fine. Irrational numbers. Non-repeating, non-terminating. Never repeats, never ends. So those are decimals. Now, instead of writing out 3.14159.262, blah, whatever, I'm just going to put pi. Matter of fact, you know what? Just to be ornery, I'm going to make it negative pi. And what's another good one? Oh, wait, the negative square root of 19. And how about, what's another one? Oh, the square root of 2, or the square root of 3, or any not perfect squares. We're going to talk more about perfect squares in a little bit, but it's going to repeat forever and ever and ever. And there you have it. Real numbers are all the rational and irrational numbers. So there we go, rational and irrational numbers. Whew, that was a lot. And on to, look at this, practice. Oh dear, this is your job. I'm gonna end the video here, and you're gonna go and you're going to practice. You're going to place the letter of each value in its proper location. If it's in more than one, put it in the one that's smallest. So for instance, let's do letter H. H is 0. Now, that is rational. It's an integer, it's a whole number, but it's not natural. So I'm going to put the 0 right there. Now it's your turn. And when you're done with that, oh no, not those 8 other problems, ew. Well, some of them are multiple choice, so it's not so bad. But try the problems, you can do this. I'll talk to you soon. Bye.